Everyone, today we continue with our chapter electricity, and this is the last part of our video series electricity. We have already discussed all the important topics and subtopics, and we were discussing the practical applications of heating effect of electric current. Okay, so in this slide we'll be discussing the light lamp holder connection. Is that we all know how a bulb looks like, right? This is the glass bulb. This is a conducting wire. We have a gas filled inside, and we have a tungsten filament, and this is the glass. Okay, so to produce light in electric bulb there is a filament. Okay, so there is a filament made of metals with high melting point that can retain much heat, so it gets very hot and emits light. Okay, tungsten is used. Now in exam they ask why tungsten filament is used. Tungsten has a high melting point of 3380 degrees Celsius. It is used to make filament. In board exam they can ask why only tungsten is used, because filament should be thermally isolated and it should be using isolated support. I think the answer is that tungsten is used because it has a high melting point, so it will melt at a very high temperature. That's why a high melting point metal is used for the filament. So tungsten having high melting point is used. Okay, the bulbs are filled with an chemically inactive nitrogen and argon gases. Why? To prolong the life of filament. Most of the power consumed by filament appears as heat, but a small part is radiated as light. Okay, now let's move ahead. Next we will discuss the concept of fuse. Okay, what is an electric fuse? Okay, so this is a very important concept. In exams they may ask you what is a fuse, what is the practical application of fuse, and how is the fuse useful, what is the concept behind the fuse. All these things are important. Okay, to make a fuse used in electric circuits. So what is the function of a fuse? Somebody can ask that. Even in board exam it can be asked. Okay, so first of all, fuse protects the circuits and appliances by stopping the overflow of electric current. Fuse is placed in series with the device. Okay, so if there is an important device that we want to protect, we will put it in series with a fuse. Okay, and what we will do is, suppose the material can withstand a 5 ampere of current, and suddenly a 7 ampere of current flows in the circuit, it will damage the electrical appliance. But if we keep a fuse that will maybe at 5.1 ampere fuse or 5.5 ampere fuse, if we keep in series with the device, when the current is 7 ampere, it will come and it will contact the fuse. Fuse will be 5.5, it will damage the fuse, but your electrical appliance will get saved. So that is the concept. Okay, so fuse is used to protect the circuit and appliances by stopping the overflow of electric current. So the fuse is placed in series with the device. It consists of a piece of wire made of a metal or an alloy of suitable melting point: aluminium, copper, iron, lead, etc. So during the overflow of the current, temperature of the fuse wire increases. It melts the fuse wire and breaks the circuit. As I told you, fuse is a device used to protect the electrical appliance. Okay, the fuse wire is encased in a cartilage of porcelain. This is a cartilage of porcelain, okay, with metallic ends. Clear? Fuse is used for domestic purposes, rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. So when an electric iron which consumes 1 kilowatt electric power is operated at 220 volt, 4.54 ampere current flows in the circuit. Okay, so what we can do, we can use a 5 ampere fuse. So if by chance the current goes beyond 5 ampere, it will damage the fuse first and our electric iron will be saved. I hope the concept of the fuse is clear to students. Okay, now we see the last concept of this chapter, the concept of electric power. See, we have seen these type of things, and the electric wire lines. Electricity is transmitted using these lines. So what is power? First of all, we should define what exactly is power. So power is the rate of doing work or rate of consumption of energy. Power can be defined as the rate of doing work or the rate of consumption of energy. Equation is H is equal to I square RT. This is the formula for heat. It gives the rate at which electric energy is dissipated or consumed in an electric circuit. This is also termed as electric power. So power P is given by P is equal to VI. We are all familiar with this formula. P is equal to VI, voltage into current, or P is equal to I square R. Where is this I square coming? Instead of V, they have used the Ohm's law. R is V by I. So V is IR. IR is come here. So I square R. Or is equal to V square by R. Instead of I square, R is V by I is V by R. So square, V square by R square. That's right, V square by R. So the same power has three different formulas. Okay. Fine. So these are the three formulas that we need to memorize. The SI unit of electric power is watt. WATT, watt, again named after some scientist. It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Okay. So electric watt, 1 watt can be defined as it is the power consumed by a device that carries 1 ampere, okay, that carries 1 ampere of current when operated at potential difference of 1 watt. Thus 1 watt is equal to 1 volt into 1 ampere, 1 VA. This is another formula that can be used for power. P is VI and P is I square R and P is V square by R. Same way, 1 watt is 1 volt by 1 ampere. If they ask define 1 volt, 1 watt, sorry, you can say 1 watt is the power consumed by a device that carries 1 ampere of current when operated at potential difference of 1 volt. Okay. So watt is a very small unit. Practically much larger unit called kilowatt is used. Okay. 1 kilowatt is 1000. 1 kilowatt is 1000 watts. Okay. Now electrical energy is the product of power and time. Its unit is watt per hour. So electrical energy is the product of power and time. Its unit is watt hour. Okay. 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour, and the commercial unit of, okay, for it is used for 1 hour. Okay, it is used for 1 hour. So the commercial unit of electric energy is kilowatt. Commercial means the larger unit. Okay, the popular unit is kilowatt hour, commonly known as unit. 1 kilowatt hour is 1000 watt into 3600 second. 1 kilowatt is 1000 watt, so 1000 watt into hour has 3600 seconds. That is 3.6 into 10 to the power 6 watt per second. That is 3.6 into 10 to the power 6 joule. Okay, 3.6 into 10 to the power 6 joule. In an electric circuit, electrons are not consumed. We pay for energy to move electrons through electric gadgets. Okay, so see, we get a bill, electricity bill like this, KSEB. What and all it has the electric unit that is used and the payable bill and everything. So in this, how much ever electricity we have used will be in kilowatt per hour. This is the energy meter. Okay. Now we have some questions that we will go through. Fine. An electric bulb is connected to 220 watt generator. Current is 0.5. What is the power? P is equal to V into I. V is in volt, A is ampere. 220 into 0.50 amps, 112 joules per second, or 110 watt is our answer. Very simple question. Electric refrigerator rated 440 watt operates 8 hours a day. What is the cost of energy to operate it for 30 days at 3 rupees per kilowatt hour? These type of questions are popular. Total energy consumed by refrigerator in 30 days, 400 watt into 8 hours per day into 30 days. This much energy watt per hour. In kilowatt it is 96 kilowatt per hour. So the cost of energy to operate refrigerator for 30 days is 3 rupees 3 se we multiply. 96 kilowatt per hour into 3, 288 rupees. Okay, done. We are done with this chapter. I really hope these classes or these PPTs that we prepared and we taught the students were really useful. And I really want students to master electricity chapter. It is very popular. It is very scoring. Important questions for this chapter can be Ohm's law, define Ohm's law, what is Ohm's law, what is electric circuit, okay, and how we calculate the resistance in series and parallel. The formula R is V by I, and all the stuff like whatever was discussed, like the heating effect of current, the practical effect impact of heating effect, like in toaster and in our electric iron, all the numericals having these simple formulas, electric power, P is VI, I square RT, all these formulas, everything, and the concept of a fuse, all these things are very important. Okay. So we end the session here, and we have also completed our chapter electricity for our class 10 CBSE students. Thanks a lot.